Hello everyone, this is Benedict from the Circuit Navigation System. In the second part of this video series we have created a simple circuit, a voltage divider, then we have made a simulation out of it and outputted that simulation as a video. In this third part we are going to edit the circuit a little bit and then we are going to make some more settings. The reason why we do this is to better understand this program. This has been the circuit of our previous part in KiCad schema, and here we have it in the CNS. Last time I was told that the lines of the wires and of the components were so thin. So for this video I have edited the line thickness in the settings. There is a parameter called Enable Strokes. Set this to yes, because then you can set the stroke thickness to a value that you like. Then click on Save, maybe Restart, and you have a line thickness that should be easier to watch. Alright, let's modify the circuit. Remove the resistor and replace it with 2 diodes. We could choose the default diode here, but we can also choose one of the many real ones in that list. Yeah, that diode here is good, okay. And another one in the other direction. Let's save the file, open the CNS, and as soon as I press the R button for reload, the new circuit is set. If you click on a component, you can add some line graphs for current, and you can read the parameters of each component. But you can also click on a wire and add line graphs for voltages here. And you can edit the color. Over here you can edit the current color. Here you can edit the form of each curve. For example, this green curve is so small, let's rescale it. Or even remove it. Let's rather edit the red curve. We can do more than just rescale, let's transform it to a step function. A value larger than -99 volt at 20 pixels below the time axis, 0 and above shall be at 20 pixels above the time axis. So now this is transformed to a rectangular looking function. There is a help document that explains all the needed function types, but the most common ones are range and step. We can also edit the drawing parameters. For example, the current arrows are a bit thin. Let's make them thicker. But now they are so close to each other, a little distancing would be good currently. Also, let's edit the range of the aqueducts to display the range from -5 to +5 volt. Everything below or above this will be cut off. We can output this as a video. I will show this video at the end. And we can output this as a table so that you can open it with Microsoft Excel or some other calculus program. We can also re-import these tables. So now I hit the R button for reload, all the values are gone, and now I start a new analysis. Not a simulation this time, but values from a dataset. Copy the path from the CSV file into the text field and click on OK. Run it, and there are the values again. So let's summarize. Use the R button to reload quickly. That's practical if you have made some changes in your circuit. You can edit things like the color of each wire and the wire thickness, and in the settings dialog there are many more parameters that you can change and about which we have not even talked yet. For example, the way how the values are displayed or the size of the text field for the line graphs. At the beginning of the video we have briefly seen a lot of editable parameters in the settings dialog. You can add and remove line graphs for currents and voltages on the time axis. You can transform the drawing sizes of the current arrows and of the voltage aqueducts. You can save your values in CSV files to open them as a table, and you can use this kind of table to edit values. That last part is especially great if you have your own values, for example from your own measuring. Then you can display them by handing them over as a table. And now, as promised, the outputted video that was created before. Okay, this circuit now looks a little bit over-edited. That's okay, because this video was about what you can do in editing, not about what you should do with this little circuit. There are often good reasons why you can make all this editing in more complicated circuits or in other circuits, and that's why it's good to have all these possibilities in editing.